Very good morning, students. I am Dr. Devashish Mohanty, working as Assistant Professor in the Department of Mathematics, SR University, Warangal, India. So today I am going to teach you about the hypothesis testing. This is very important to predict whether the statement is true or false. Means whether we are accepting the null hypothesis or fail to accept the null hypothesis based on the given statements. So let us coming to today's topic based on the hypothesis testing. Students, see here, this is about the hypothesis testing. So here we can see that the definition of the hypothesis testing. The hypothesis testing is a statistical method that helps to determine if there is enough evidence in the sample of data to infer that a certain condition is true for entire population. So that is very important, student. So hypothesis testing is a statistical method. So this is the definition. Is a statistical method that helps to determine if there is enough evidence of the sample data that a condition is true for population. So this is very important, student. This is about the hypothesis testing. Okay. So here the properties, some properties of the hypothesis testing are there. So the first property is it is a fundamental tool is in the inferential statistics. So it is a fundamental tool in inferential statistics. This is the first point. Second point helps to helps in making decisions. Either we are accepting or not accepting based on sample data. In the third point, it provides a framework for testing assumptions. For testing assumptions and claims. Okay. Next, coming to the next thing, that is how to test the hypothesis, right? So here, students, we can see the examples of the hypothesis testing. The testing whether a new drug is more effective. Testing. These are the examples. Whether a new drug is more effective than a than an existing. So this is the example. Taking a if a coin is biased towards the heads or tails. Also that is important. So either it is a head or it is a tail. That way, if whether by which we are checking. That is also important. And determining that is very important. Determining if a new teaching method improve Improve student performance. Improve students' performance. Okay. So these are the examples of the hypothesis testing, students. So next, after that, coming to the null hypothesis. So which is very important, null hypothesis. So null hypothesis means it represents the default assumptions or status. That is the null hypothesis. It assumes no effect or no difference. So no effect or no difference. That means the mean weight of apple is 150. The mean weight of apple is 150 gram. That's the thing we have to see. That is the null hypothesis. Okay, students. So this is about the example of the hypothesis testing and what is a null hypothesis. Next, coming to the alternative hypothesis. So two types of hypothesis are there. One is null hypothesis, another one is alternative hypothesis. If the null hypothesis is given the statement, if any statement is given, suppose Ram is a good boy, the alternative hypothesis Ram is not a good boy. So like that. So it always prevents the null hypothesis. That means contradicts to the null hypothesis. Right? So represents what we are trying to prove and contradicts null hypothesis. So very important. So it always contradicts the null hypothesis. Suppose this is the null hypothesis. The alternative hypothesis HA is always contradicts the null hypothesis. Contradicts the null hypothesis. Very much important for this. The mean weight of the apple is 150 gram. The mean weight of apple is not 150 gram. So if the null hypothesis is mean weight of apple is 150 gram, the alternative hypothesis will be automatically the mean weight of apple is not 150 gram. So that is the thing, students. Means in case of any alternative hypothesis, it always contradicts the null hypothesis. It is not following the null hypothesis. Right, students? So already I have shown you in the previous lecture about the one-tail test and two-tail test. So it is also very much essential in case of the hypothesis testing. So how we can predict the now that hypothesis testing is one-tail test or two-tail test, right? So here we have to see this definition one-tail. One-tail test if a parameter is greater or smaller than a value, specific value. That means HA such that mu is greater than 50. So either it is a greater or it is a smaller. So that is a one tail. Again, what is two tail? Then test if a parameter is different from a value. Is different from a value. That means HA alternative hypothesis is mu is not equal to 50. So here either it is greater or smaller, here different from a value. Different from a value means not equal to. The alternative hypothesis is not equal to that specific value, that HA, such that mu is not equal to 50. Here HA such that mu is greater than 50. So that is those are the differences. This is the basic difference. Either it is a one-tail test or you can say that is a two-tail test. Next, coming to the important thing, that is the left-tailed and right-tailed test. So what is the meaning of left tail test? The test whether the parameter is significantly smaller than a hypothesized value. So that means left tail means x naught such that mu is greater than equal to mu naught, or the alternative hypothesis is representing mu is greater than mu naught. That means smaller than a hypothesized value. Okay, mu is less than mu naught. Here you can see mu is less than mu naught, alternative hypothesis, and the null hypothesis is mu is greater than equal to mu naught. So that is called as left tailed. That is the left tailed test. Similarly, if we go for the right tail, so in case of any right tailed test, so here the x naught similarly mu is less than equal to mu naught, and alternative hypothesis is mu is greater than mu naught. That means the critical region is in the right tail of the normal distribution. So here the critical region is in the right tail of a normal distribution. Right? This is the right tail. So students, after that, see this table. So this is about the left hand and right hand concepts. That means here is the comparison parameter. So in the comparison parameter here you can see that HA is the alternative hypothesis and H naught is the null hypothesis. So if the alternative hypothesis is not equal to means automatically the null hypothesis will be equal to. If it is greater value means it is always less than equal to. And if it is lesser value means it is always greater than equal. So this is all about the comparison operators. So whenever suppose of the null hypothesis is not given that mu is equal to mu naught, the alternative hypothesis will be automatically mu is not equal to mu naught. That is the thing that is in case of two tailed. Two tailed means here we can see that is only this is very important alpha y2, and here is also alpha y2. That is two tailed. But in case of one tail, that is alpha is always 5%. In the right, either if it is the greater than value, and it is left, either it is alpha is 5%, left side. So these are the tails of test which we have to follow to find out the left tail or right tail test. Okay, students. So try to understand three things. First one is if it is equal means suppose H naught is equal, that is null hypothesis, alternative hypothesis is not equal, that is a two tail test. And if H naught is less than equal to and HA means alternative hypothesis is greater value, then it is one tail right. And if the null hypothesis is greater than equal to and alternative hypothesis is less than, then one tail left. So these are the very important things. Next, this is the most important thing we have to follow to solve any kind of problem. So here, this is the main procedure of the hypothesis testing. So step was we have to understand how we can follow the hypothesis testing procedure. So in the first step, we can see here define the null and alternative hypothesis. This is the first step. Define the null and alternative hypothesis. This is the first step. In the second step, choose the significance level. Choose the significance level. Choose the significance level means alpha value. In the third step, we have to select the appropriate test statistics. Select the appropriate test statistics. That is in the third step. And in the fourth step, we can see compute the test statistic value. So in the fourth step, we have to compute the test statistics value. So here you can see the next step is step 4. Compute the test statistics value. In the step 5, compare the critical value. Means p-value. Compare the critical value, or we can say that is a p-value. That is very important. Critical value. We have to compare. So, students, in which case we are rejecting the null hypothesis, and in which case we fail to reject the null hypothesis. That is also very much important. So, if the statistical value is lying between the critical value, then we fail to reject the null hypothesis. If it is not lying, so we reject the null hypothesis. Those are two cases. So, based on that, step 6, this is the last step. So, we have to make a decision. Which decision? We have to make a decision that we will reject the null hypothesis or else we fail to reject the null hypothesis. So students, this is very important. Means these 6 steps are very important for testing the hypothesis. These are the basic procedures. Starting from the step 1, like we have to define the null and alternative hypothesis. In the step 2, we have to choose the significance level, alpha value. In the step 3, we have to select the appropriate test statistics. In the step 4, we have to compute the test statistics value. And in the step 5, we have to compare the critical value. We have to compare the critical value or p value. This is very important. And either based on these 5 steps, we have to state that either we will reject the null hypothesis or we will fail to reject the null hypothesis. These are the basic things, students. We have to follow the basic things. Okay. Right. So next, coming to the problem, here is the selection of the significance level. Means how we select the significance level. The significance level is a probability of rejecting the null hypothesis when it is true. So what is significance level? Let us know. Significance level. Significance level means that is denoted by alpha. That is the probability of rejecting the null hypothesis. Probability of rejecting the null hypothesis. And here is the common sources, means most common sources. Already I have told you students 95, 99, and 90. Most common sources is 95 means 0.05, 99 means 0.01, 90% means 0.10. So students, these are the most common sources for selecting the significance level. Means basically in hypothesis testing in each problem, you can see this. Means either it is a 95% means 0.05 level of confidence, 99 means 0.01 level of confidence, and 90% means 0.1. Okay. Based on this concept, the lower alpha means stricter criteria for rejecting the H naught, means null hypothesis. That is the most basic thing here. Okay. So next, coming to one problem, a company claims that average lifetime of its light bulb is 1200 hours. So students here have to identify either it is a X bar value or the mean. So it is X bar means what? Sample mean. So here the sample with respect to sample 40, the mean is given 1180. So don't be confused. So here the mu value is equal to 1200 hours. 1200 hours. and sample size n is equal to 40 volts. And the mean lifetime, that is x bar value, is equal to 1180 hours. Standard deviation sigma is equal to 100 hours. So these data are given. The significance level is alpha is 0.05. Right? So these things are given in this question. Try to read this question again. A company claims that the average lifetime of its light bulb is 1200 hours. A sample of 40 bulbs has a mean lifetime of 1180 hours and a standard deviation of 100 hours. So test the claim at alpha is equal to 0.05. Right? So here, students, the first step, the step one is we have to choose the null hypothesis and alternative hypothesis. So here the null hypothesis is given mu is equal to 1200. The alternative hypothesis is given mu is not equal to 1200. So it is a two-tailed test. Already I told you, two-tailed test. As S naught is equal and SA means alternative hypothesis is not equal. So one is equal value equal to, so means null, in the null hypothesis we are assuming that the mean is equal to 1200 hours, means average lifetime. And in the alternative hypothesis also similarly we have to check that mean mu is not equal to 1200 hours. So both things are very important. Okay, students. Next, coming to the significance level alpha value. Alpha is equals to 0.05. So here the significance level is given. Alpha is equal to 0.05. Right. So in the step 2, we have to follow that. Alpha value is equal to 0.05. This is the alpha value. And in the third step, we have to test the statistics. So to test the statistics, we have to apply the formula Z is equal to x bar minus mu divided by sigma divided by square root of n. So this is by the applying this formula, we can calculate this Z value. So here we have to test the statistics. Z equals to 1180 minus 1200 divided by 100 divided by square root of 40. So that value is minus 1.26. Right. So this by this way you can test the statistics, that is 1 minus 1.26. The next value is we have to find the critical value for given alpha is 0.05. So students, it is very important. The given alpha value is 0.05, right? So it is a two-tailed test also. Also I have mentioned why two-tailed, because mu is equal to, we have given 1200 and mu is not equal to 1200. So two cases were showing here. So for that reason only, it is a two-tailed test. So for two-tailed and alpha is 0.05, our what is the critical value? Already I have told you in the table, the critical value will be two tests and 0.05 plus or minus 1.16. And what is the statistical value? Means Z value, that is minus 1.26. So minus 1.26 is lying within plus or minus 1.96, is not it? So if it is lying in this value, so we fail to reject the null hypothesis because it is lying in that value only. So we fail to reject the null hypothesis. That is very important. Fail to reject the null hypothesis. Why? Because this value already lying. So I have already explained you students, in which case we will fail to reject the null hypothesis and in which case we reject the null hypothesis. So fail to reject the null hypothesis in the case is that Z value, statistics value, lying between the critical value. If it is not lying, that means between the critical value, that means we reject the null hypothesis. Simple thing. Those are the conditions. Okay, so this is the problem. Now, this is very important. The second problem, a factory claims its machines produce item with an average weight of 500 grams. A sample of 30 items has a mean of 490 grams with a standard deviation of 15 grams. Test the hypothesis at alpha is equal to 0.01. So students, in this question, the average weight mean mu is given 500 grams and XOR value that is given 490 grams. Standard deviation sigma value is given 15 grams. So we have to, students, we have to check the statistics. Hence, we have to test at alpha is equal to 0.0. Right? So here we have to check the null hypothesis mu is equal to 500 and alternative hypothesis mu is not equal to 500. Those two values we have to identify and we have to check. Right? So coming to the solution part. So here is the solution, students. So stepwise we will go. Okay, stepwise we will go. So, let us see. So first step, that null hypothesis mu is equal to 500. Alternative hypothesis mu is not equal to 500. This is the first step. We have to define the null hypothesis. After that, we have to define the alternative hypothesis. After defining the null and alternative hypothesis, in the second step, we have to write the significance level. So step two, we have to write the significance level. So what is the significance level, students? Already it is given in the question. That is the alpha value. That is 0.01. This is the significance level. After defining the significance value, we have to, in the third and fourth step, we have to test the statistics, means Z value. So how to define the Z value? That is x bar minus mu divided by sigma divided by square root of n. That is very important. So let us see here. Step wise we have to write, otherwise it's very difficult to understand. So step 3 and 4, both the steps, you have to test the statistics using the formula x bar minus mu divided by sigma divided by square root of n. So x bar is 490, mu is 500 divided by sigma is 15 and square root of n is 30. That value we are getting minus 3.65. This is the third and fourth step we are getting the Z value. That is minus 3.65. Right? So after finding this Z value, we have to find in the next step the critical value. Critical value means at alpha is equal to 0.01. So students, from the question, can you tell me what it is, a two-tail test or one-tail test? Obviously, two-tail. Why? Because the null hypothesis is equal sign, mean is equal sign, and null hypothesis of that one is equal, and alternative hypothesis of that one is not equal. In case of any equal and not equal both, so we have to apply two-tail test. So as we are applying the two-tail test, so here we will get these values. Means two-tail test, we are getting the Z value as minus 3.65. So two-tail test means alpha equal to 0.01 at significance level. What is the value? Already I have shown you the table. Yes, tell me. What is the critical value? The critical value is plus or minus 2.576. Right. In the next step, we have to check whether we will reject the null hypothesis or fail to reject the null hypothesis. So how we can check what is the condition? The condition is the minus 3.65 is less than minus 2.576. Minus 2.576. So we generally we reject the null hypothesis. Why? Because this minus 3.65 not lying between minus 2.576 to plus 2.576. As the critical value is not lying between the statistic value, so we reject the null hypothesis. If it is lying means we fail to reject the null hypothesis. These are the simple things. Okay. So next, coming to the next problem, a researcher claims that the average height of a student in a university is greater than 170 centimeters. It's always greater than 170 centimeters. So students, this mu value is 170, right? This n value is 50 students. So sample of 50 students. And x bar value is 172 centimeters. And standard deviation is sigma value is 5 centimeters. Alpha value is 0.05. So as all these values are given, so we can implement those values and we have to check. But can you tell me it is a one tail test or two tail test? Here, here you see here the university is greater. It's greater than 170 centimeters. So it is not the average. It is the greater. So one tail right or left we have to define. So right. So here we have to count. That is one is greater than one is less than equal. So one tail right tail. Right. From the question, we can identify those things, right, students? So in the step one, we have to define the null hypothesis. So for defining null hypothesis, mu is less than equal to 170 because everyone is greater than 170 centimeters. So mu is less than equal to 170. So they again the alternative hypothesis will be definitely mu is greater than 170, right? So as it is one tail test, you can define the set, na? Right? So after defining the significance level here given alpha value is 0.05, right? So alpha value is 0.05. After defining the alpha value, we have to test the statistics. So how to test the statistics? Now z value that is equal to 172 minus 170 divided by 5 divided by square root of 15. What is this formula? X bar minus mu divided by sigma divided by square root of n. So that is 2.83. Right? So after defining these values, we have to find the critical values. How to find the critical values? Yes, tell me. The critical values alpha is given 0.05, so it is a one tail. It is a one tail test, so this value is 1.645. And the Z value is 2.83. So as 1.645 is less than 2.83, so we reject the null hypothesis. Directly will reject the null hypothesis. Right. So it is a one tail problem. Already I have solved two tail problems. So based on that, you can identify whether it is a one tail test or two tail test. And after defining it is a one tail test or two tail test, first of all, in the first step, we have to define the null hypothesis or and alternative hypothesis. A null hypothesis, if it is a two tail test, null hypothesis will be equal sign, alternative hypothesis will be not equal sign. If it is a one tail test, so either it is the right or left, greater than value. So means mu is less than equal to 170, alternative automatically will take mu is greater than 170. And significance level is 0.05. And with the statistical value, we can find x bar minus mu divided by sigma divided by square root of n. This formula to implement there, and we can find this value 2.83. After finding this value, we have to find the critical value. So how to find the critical value, students? That is alpha equal to 0.05 means one tail, and that value is 1.645. So if it is lying within this value, then we fail to reject, or else we will reject the null hypothesis. So these are the basic things actually. So using those things, we can easily identify whether we'll reject the null hypothesis or not. These are the problems we have discussed already. So here is the type 1 and type 2 errors. So write down type 1 and type 2 errors. So in the type 1 error, rejecting a true null hypothesis. That is alpha error. And in the type 2, in second type, failing to reject. Failing to reject a false null hypothesis. False null hypothesis. That is theta error. Okay, students, this is the type 1. This is all about the type 1 and type 2 errors. After that, this is the acceptance and rejection table. In which case we will accept the null hypothesis, and in which case we have failed to reject the null hypothesis. That is very much important. So here, in the first one, means in the reject null hypothesis, that is about the type 1 error. And the null hypothesis is false means we have the correct decision. Null hypothesis is true means that is the type 1 error. Similarly, fail to reject case. Fail to reject. That's not. That means if the null hypothesis is true means that is a correct decision. And if the null hypothesis is false, that means type 2. So students, this is all about the type 1 and type 2 error. And based on the null hypothesis, we have to determine the statement that whether we are rejecting the null hypothesis and fail to reject the null hypothesis. So in this today's lecture, we have seen that how we will determine means how we will test the null hypothesis, or how we will test the hypothesis based on given the mean value. Either it is a two-tailed test or one-tailed test. So if it is two-tailed, then how we can proceed, and with all procedure we have seen that how we can proceed with this hypothesis. This is very important. These steps are very important, students. These 6 steps are very important for the question or hypothesis testing. In the first step, we have to define the null and alternative hypothesis. We have to choose the significance level. We have to select the appropriate test. We have statistics. We have to compute the test statistics. We have to compare the critical values. And after that, automatically we have to make a decision that we will reject or fail to reject the null hypothesis. So these are very important, students, for your exam. So keep practicing on for this hypothesis testing. Okay. So already we have discussed everything. So thank you all. Thank you for listening.